All right, so you got an equation here. It says minus 1/2 absolute value x plus 10 greater than or equal to minus 5. I made some comments a while back about if it's greater than or equal to a negative, that could always be true, but you have to isolate the absolute value before you can make that determination. So basically, you need to get rid of this.
Yeah.
And like you could say, well, let me divide by negative 1/2, which is totally true and correct. It's preferred to multiply by -2.
It's preferred to multiply by -2. Okay. That's what I was sort of thinking when I was doing it.
Yeah, so I'm going to do it that way. I'm going to multiply both sides by -2. Now, whenever you multiply or divide by a negative, in this case, -2, you switch the inequality. So this is your new inequality.
All right, so then the part I have trouble remembering is, do I make it like a plus minus type thing, or?
So this is the between case. Less than or equal to is always the between case. So you put 10 here, -10 here, and then x plus 10 right in the middle.
Right. And then you 5 and 2? No, I'm trying to just remember this next step.
You subtract 10 from both sides because you want to get
totally by itself.
Yeah. So you get -20 less than or equal to x less than or equal to 0.
And then is that it?
That's it. It does say to graph. It says using interval notation. So on a number line, what we're looking at is -20 and 0, and filled in dots because they're less than or equal to's, and then everything in between.
Okay. All right. And then if it's the the graph's pointing the other way, then it's going the not. All right. I just want to do a couple more of these.
Yeah, that's the next thing, is to actually give you some that are like this. So we'll go with a -1/3 absolute value x plus 4 greater than or equal to -6. So this one's, again, it's probably almost exactly like the previous one, just different numbers. I mean, it would be good for you to try on your own.
All right.
And I can walk you through it if needed.
So my question is, would I be multiplying it by -3?
Yes.
Okay. All right. Oh wait, I can't keep doing that. My bad. All right, I guess I'm a little bit confused.
Okay. Did you multiply both sides by -3?
Yes, that got me x plus 4 is greater than or equal to 18.
But you have to flip the sign when you multiply or divide by a negative.
Oh, right.
So you flip when multiply or divide by a negative.
And then I write -18 is less than or equal to x plus 4, and then which is less than or equal to 18.
Yes.
And the 18 on the far left symbol changes because it's a negative, right?
You always put the positive one right below it, and then you negate it over here when it's the less than or equal to. That's the between case, because you can see you're between two numbers. So you're going between them. That's why it's the between case.
Okay. So would it, so when it's between the negative, we'll make that like caret change.
When it's a less than or equal to, it's always between.
Okay. So it'll always be facing that direction.
Yes.
All right.
So from here, you subtract 4 from everything.
Okay, so then minus 22x and then 14.
Yes.
And then do I do anything else past that?
Nope, because you got x by itself, don't you? See how there's no operators in here? There's no numbers, there's no multipliers. It's just x.
Okay, yeah. And then you can graph that by just going
Yep, you make your number
minus
line, and I'm
22 and then 14, and then you make the line going from those in between.
yep, and I'm just arbitrarily choosing places on there.
Yeah, those aren't like accurate, or it doesn't matter.
That's right. Okay, let's have you try another one here. Just give it, as much effort as you can on your own here. Let's go x plus 2 greater than or equal to -2.
All right.
Give this one a try, please.
All right. I think I got it.
Okay, so tell me your absolute value here. What goes to the right here?
Greater than or equal to 8.
Is it this symbol or something else?
It's that symbol.
Okay, but you multiply or divided by a negative, didn't you?
Oh, right. So it has to change.
Yes.
And then the next part I got was minus 8 is less than or equal to x plus 2.
Yep.
And then it's less than or equal to 8.
Yes.
And then I got minus 10 is less than or equal to x, which is greater than or equal to 6.
Yes.
Okay. Cool.
Okay, so I need to give you more of these because you got to be really solid on these. So let me give you a new one. Negative absolute value 2x minus 1 is greater than or equal to 3.
All right.
I'm going to be right back.
Sounds good.
All right, hey Zach, how are you doing on this one?
I've finished, I think.
I messed this up. I'm so sorry. This is supposed to be -3.
Okay, I was gonna say this one was a little easier.
Yeah, so now, yeah, so if you did it the original way, you would have gotten all solutions, but this was the correct one, which is, so I'd like you to try solving it from here. If you can, please.
Well, okay, the thing is I did kind of get that because I was moving that negative over.
Okay, so yeah, but go ahead, go ahead and make these changes because the problem I gave you wasn't an accurate type of question. You'll
All
see.
right. 2x minus 1 less than or equal to -3. Switches, and then I got 3 is less than or equal to 2x minus 1, which is less than or equal to -3. And then for my final part, I got 4 is less than or equal to x, which is less than or equal to -2.
Don't you have to divide by 2 now because you got 2x?
Oh, right. And then that would just be 2 is less than or equal to x, which is less than or equal to 1, right?
Yes.
Okay. I do have one question where it's, so they have like there's like 2 ways to solve that one problem. Like,
Yeah, that's the next type, the greater than or equal to problems.
okay.
So let's look at a few of those. Let's say absolute value 3x minus 2 is greater than or equal to 6. Okay, so the greater than or equal to is the outside case. So the outside case is what you're referring to, where you have to write 2 of these.
Uh-huh.
So you write 3x minus 2 greater than or equal to 6, and then exactly the same thing, but you flip the inequality and negate this.
3x minus 2. So what's different about this one compared to the other?
Well, let's keep going. Let's keep going here. So how would you solve each of these?
I just add 2 to the first one and then have to divide it by 3.
Yep.
And then the other one I would add 2 again and then divide by 3.
Okay, very good. So now you're divide by 3, divide by 3. So x is less than or equal to -4/3. X is greater than 8/3. So I'll put these on a number line. Here's -4/3. Here's +8/3. Less than or equal to -4/3 is over here on the left. Greater than or equal to 8/3 is over here on the right. So do you see the difference? Do you see why I call this the outside case?
Yeah. Oh, right. Because it's like that inside area isn't filled
Yes.
up with the other. So when the signs are going opposite directions, it's an outside.
Well, no. The greater than or equal to is what causes it to be the outside.
Uh-huh.
Once you get it down to the absolute value.
Okay. All right. And I guess I get that now with how there's the no negative or other number in front to divide it, which would change it up.
Yeah.
And then, so can you solve that problem doing the other way?
No.
So then how would I solve this problem showing like both? Oh, let me try and find its exact name.
Let me try to explain like this. This is let me show you what, because here's what I think you're asking. Here is problem number 1, x minus 3 absolute value less than or equal to 9. Here is other type of problem, x minus 3 greater than or equal to 9.
Uh-huh.
This one on the right, and I'm sorry, this one on the left has the following solution. So just believe me for a moment here as I do this. Let me think about that. 12 and -6. So here's well, actually, let's just do it. This will be better exercise for us to do. This is x minus 3, -9, and +9.
Mm-hmm.
Add 3, add 3, add 3, -6 less than or equal to x less than or equal to 12. So on a number line, it's all the numbers between -6 and 12. Between. Okay. Now let's do the other one. And it's okay if you just follow along here. You don't have to actually do the work.
All
Because
right.
you're gonna see something very, very important here when we're all done. So you add 3, x greater than or equal to 12. Add 3, x less than or equal to -6. So notice we get the exact same numbers.
Uh-huh.
That shouldn't surprise you. All the numbers less than -6 and all the numbers greater than -6. So when it's less than or equal to, you get between. When it's greater than or equal to, you get the outside. Inside and then outside.
All right.
And it all comes from this, the
Just that
inequality.
one symbol like totally determines that.
Yeah, it changes that. So what you have to be able to do is identify, and that's what I was trying to get at. You have to take, a given problem, whatever your instructor gives you, and figure out which one it is. But you have to solve for the absolute value. You have to get the absolute value by itself, because there's many exceptions to this. But by getting it down into this form, you then know how to solve it from there.
Okay. So then, could you scroll up just a little bit to that original part? Okay. Given problem.
Yes.
So,
And you may have to do some, you may have to move some stuff around. You may have to move, you may have to add, subtract, multiply, divide.
so is it like asking me to prove it with like the other way to do it?
No, but like, okay, what I'm trying to say, let me give you a problem. Let me give you a problem. -2 absolute value x minus 3 plus 4 is less than or equal to -8.
To -8.
So is this a less than or equal to problem or a greater than or equal to problem?
It will be a greater than or equal to problem since you're moving a negative. over.
Probably, but we should do the steps first. Like, and that's the whole point, is you're supposed to do these steps. You're supposed to subtract 4. And then you're supposed to divide by -2. And what does that do to the inequality? When you divide by a negative?
Oh, it changes the direction.
Right.
Well, I shouldn't say that way, but and then
So
what do
there
you
you go. So that is it. That is,
so then that would be like x minus 3 is greater than or equal to 6, and then x minus 3 is greater than or equal to -6.
it's this right side though. Yeah, you have to create the two cases. But do you see how we couldn't figure that out from the beginning?
Yeah.
We have to do all this work.
I do see that. So you have to show that. So there's like always just one way. Like there's always one that actually.
Yes, that is the answer. There's only one way to solve it. It's not like the factoring or the quadratics where you gotta like pick the method. There's only one way to do these.
All right. So then if a question ever asks like show both ways,
No, it wouldn't. It would never ask that.
Okay.
That's like a fundamental flaw. You would never be asked to do it both ways.
Okay.
Because what you're thinking of is like solve by factoring, solve by completing the square. No, you would never do that.
Okay.
For these, it's only just solve. Okay, let's look at some other problems here on your worksheet that could help answer some of these questions also. So here's a problem C. So do you remember what you did here when you worked on this problem?
I made all the denominators 12.
Yes, you multiply. Well, you actually just multiply everything by 12 because that'll get rid of the denominator. So
Alright.
and I know the tendency is to multiply first and then divide, but it's actually better to divide. 12 divided by 3 is 4. 4 times 2x is what we're trying to do here. Minus 12 divided by 4 is 3 times x, and then 5 here.
Okay, so then that just eliminates that.
Right. So
then
this is 8x minus
3x
3x.
is greater than or less than 5, and then that's just x is less than or equal to 1.
Right. And there's no absolute value, so you don't have to do anything here.
And that's it?
That's it. There's nothing more to do on that one. You actually don't have that many absolute value inequalities problems for whatever reason. Maybe let's try another one here. Absolute value 5x minus 1 over 4 is greater than or equal to 2. Do you want to try solving this one on your own, please?
Sure. All right, I think I got it.
All right, so did you write the two equations here? 5x minus 1 over 4 greater than or equal to 2. 5x minus 1 over 4 is less than or equal to negative 2.
All right, I did not do that.
Okay, so this is the greater than or equal to. That's like, I don't know if it's flashcards, but you need to like, all right, that symbol, what do I do? And then
All
the
right.
symbol,
I
what do
did
I
the
do?
one on the left, I guess.
But this one's absolute value, right? So there's always two equations, or it's a between for absolute value.
Okay. All right, I only did the one on the left.
Okay, so did you solve it, this one on the left?
Yeah,
Did you multiply both sides by 4?
I did.
Okay, so
Oh, wait,
does
so that make it- okay.
that flip the inequality?
No.
No. Then you
Nothing.
add 1. 5x is greater than or equal to 9. So x is greater than or equal to 9/5.
Yeah. Huh, I did this. I don't know, I did it kind of weird where I wrote it. It's 5x minus 1 is less than or equal to -8 and then the +8 instead of just doing that.
But so that is not correct. You cannot do it that way. Like it's
That doesn't apply to
it's
either.
completely wrong. Like even though it feels like it's the right thing to do because it's
You've just been doing that before.
yes. So that's why it's so important. You got to recognize, is it greater than or equal to or less than or equal to? Which one is it, and which path do you go down?
All right.
So
all right,
here,
let's go to flashcard thing for that.
yeah, if that's all you take away from tonight, that's a lot, because you really got to be solid on that. It's I don't know, the analogy I'm thinking of is like, which way is left and which way is right. That it's not correct the other way. It's completely like, you're driving now, someone tells you to go right and you go left. I mean, you cause an accident. It's like, that's in math, it's that incorrect.
All right. And then that one.
Okay, so do you want me to give you some more inequalities, absolute values?
Yeah, I think so.
All right, let's do this. Let's go.
Like to do before this ends is that the like first page where it has the graph on it with set builder notation, interval notation, stuff like that. Because
Sure. Yeah. Okay. Yeah. Let's do one more of these. So we got -3 absolute value. X minus 4 is less than or equal to -12.
all right, so have to, I guess, divide by -3.
Nope.
Sorry, what?
No, yes, yes. Sorry,
Oh, okay.
I'm exhausted.
Yeah, it's
So
all good. It's all
I'm pretty
good. I just
much,
couldn't hear you too well. So that would be x minus 4, the sign changes, and then that would be +4.
yes.
And
So do you have what I have written here?
yeah, same exact thing.
Okay. Now this, your flashcard here will show you that it's this. It's the two scenarios.
X minus 4 minus 4. So then it would be x is greater than or less than 0, and then x is greater than or less than 0. How? No, it's 8 and then 0.
That's right.
Okay, wait. You know what? Maybe I did do that for that other one too, and I just did it like in a funky way
Okay.
because the answers for the past one was -7/5 and +9/5, right?
Yeah.
Okay,
I mean, as long there is the idea that if you're right, it doesn't really matter how you got there, but you really do want
yeah,
to follow the proper conventions if you can,
yeah,
because
that's
this does
how.
come back. I mean, you're
Yeah,
gonna
I'm
see
just
this
trying to
again.
figure out like what I guess I turned both. So it's like I figured it out doing it one way, and then I just made it plus minus, but I'm gonna stick to that. I don't know like why I did that, but I guess it somehow worked. But for this one, that makes sense.
Okay, great. So let's look at your we'll look at this problem that you have on your worksheet in a moment. But I'm going to make one like it. So let's say f of x equals absolute value x minus 3 minus 2. There's a standard form here, which is absolute value x minus h plus k. And the reason this is so important is it tells you the vertex. The vertex is at h comma k, and that's the v. That's this point or this point, basically. So it's really important to get that vertex because it leads you to the domain and the range. So like for this problem over in the left, the vertex is 3 comma minus 2.
3 comma minus 2.
Now take a look at that and look at the previous line and tell me, look at it and be like, okay, I get it.
Yeah, I get that. Because those are like the two numbers, and then the one in the absolute value is x, and then the one outside is y. Or am I crazy?
I'm sorry, say that one more time.
Is the one inside the absolute value like x and the one outside like
Yes,
y?
exactly. Yeah, this is
All
x
right.
and y. Yep. But you can see it's x minus 3, but it becomes positive 3. But this one on the right stays the sign. So graphing, it's important here. We're going to go to 3 minus 2 right there. And then because there's a 1 out front, that's your slope.
Mm-hmm.
And because it's an absolute value, it mirrors it. So you get a graph that looks like this.
So
And that's important.
is your slope, that's just a totally normal problem, right?
Yep.
Like that's almost like the baseline. Like that's the same as if it's just like 0, 0.
Yes. Yep.
But then if that number outside was 2, then the y values and that would go up by 2.
Yeah, you'd have a slope up 2 over 1, up 2 over 1, up 2
Okay,
over
so
1.
the 1 is basically the equivalent of just equivalent of nothing being there.
Yes.
Okay.
Okay, so the domain in set builder notation, the domain of these absolute values is always all real numbers, x such that x is an element of the real numbers. Always, always, always.
So then, and then the range
Range
is
depends
the
on whether it
y
opens up or
values.
down. It depends whether it opens up or down. Since this one opens up, you take this
It's
y
the
value.
y is greater than, right?
Greater than or equal to -2.
And then what if, let's say that graph was -1 and it would be facing down.
Be y less than or equal to -2.
Okay, so it's always going to be that -2. So that second number in that.
Yes, and that's set builder notation.
Set builder notations.
So interval notation, we're going to do off to the right here. Set builder notation is not too bad. You actually already know how to do this. All real numbers is -infinity to infinity. This means all real numbers.
All right. So then.
So this other one, you actually just make a number line. You put -2 on there.
Mhm.
You go to the right. How far to the right does it go? Well, it goes to infinity. Bracket -2 because it includes it
Mhm.
all the way to infinity.
So would it always be number and then infinity?
If it was the other way, like you said, if it was y
Oh,
less
just
than or equal to, it
negative?
would be -infinity to the number bracket.
Okay. All right. All right, I guess that makes more sense now, that infinity thing.
So like, let's do this. Let me give you a couple of set builders to convert to intervals, because I think that's could be a stumbling block here. So let's say it's y less than or equal to -3. So this would be -infinity to -3. Because graphically, here's -3. It's all of these numbers.
So it's 3 numbers to the left.
So it's everything. It's everything from -infinity up to -3.
Okay.
Now, what if it was y greater than or equal to 7?
Then it would be going to the right.
Yeah, yeah. So it's all the numbers starting at 7 going up to,
Infinity, and then
yes,
infinity of numbers, like it goes on for ever negative. So once it hits -3, that's like the end.
yes.
Okay.
Okay, so now that you have this down, I'm going to give you some more absolute value equations, and I want you to find the vertex. So f of x equals absolute value x plus 1 minus 3. So what is the vertex on this one?
Your vertex is 1 and -3, and the 1 is x, -3 is y. So
Let's go back. Let's go back and look at our problem here. See how it was x minus 3. See how it's x minus h. So just another little tiny thing to remember, of course.
So it makes it a negative number.
Yes, it's -1
and -3.
-3. Yeah. So now if we were to graph that, well, let's go find that place on the graph. -1, -3.
And
It's a
then
slope of 1. So you have a graph that looks like this. And what is the domain?
x/x er
Element of the real numbers. And
yeah.
how do you represent that in interval notation? So how much of the number line is
-3 infinity?
No, it's everything. It's
Okay.
-infinity to infinity because it's everything.
Oh, right. That's your domain. It's just -infinity.
Yeah. Your range is y such that y is an element of the real numbers, comma, y. Is it greater than or equal to or less?
Greater than -3.
Very good. So again, on your number line, there's -3. It's all of those numbers.
All right. And then that would be -3 and infinity.
Yes. Now it's bracket -3 to infinity.
Okay. Is it why is it bracket and then like quotation mark, or not quotation mark?
So the following symbols always go together. And then infinities always go with parentheses. So if you ever have one of these, you use the same kind of symbol, like a dot goes with a bracket, dot goes with a less than or equal to, and so on.
All right. I guess that's interesting.
Yeah, it's a kind of a shortcut there. So now let's have you try a problem here. Let's say f of x equals 2 absolute value x minus 2 plus 4. Can you give me the vertex on this?
-2 and +4.
So as a reminder, it's x minus yep.
+2 and 4.
Yep, it's that easy to mess it up. Now the nice thing is that 2 actually doesn't impact your range.
That's good.
Okay, so give me your range, because that's really what we care about. Y such that y element of the real numbers.
Y is greater than or equal to +4.
Right, because these have all opened up.
Mm-hmm.
And that corresponds to bracket, because of that symbol right there, greater than or equal to 4 to infinity. Infinity always goes with parentheses.
All right, and then that would be 4 to infinity. So then that would just be starting at 4.
Yes.
Every number to infinity.
Yes.
And then to graph this on a actual, so you go 2 over to the right, 4. So 2 over and then 4, and then you'd multiply all those like y values by 2 and you put it on.
Yeah, you end up having a slope of 2. I mean, this doesn't scale well, but something like that.
Okay.
Let's try another one here. Let's go f of x equals negative absolute value x plus 4 plus 8. What is the vertex of this one?
-4 and +8.
Does this open up or down?
This is going to be going down since there's a negative out there.
Right. So what is the domain?
The domain is going to be y.
Domain, not range. Domain is x. I know I only asked you for range in the last one, but domain.
Is that? I mean, that's it, right?
That is it. Now, how do you express in an interval notation?
How
do you
8 and then to infinity?
But if it's 8 to infinity, that leaves out all these other numbers.
Wait a second. That's because it's negative. It's gonna be in negative infinity to 8.
To infinity.
Oh my God. Okay, sorry. I was like overthinking that.
Well,
Yeah.
I'm not giving you exactly the same problem each time. Like one of the things we've worked really hard at, and you maybe didn't even know that I was doing this over the years. Like I'm trying to not just give you exactly the same question every time.
Yeah, I have noticed that. I like that.
I'm like initially I did, but like we're trying to break you free from that.
Yeah.
So this is also a note card, by the way. Like this and this, you need to know that those are
the same. Yeah, because that's just like the blank slate, and then that infinity symbol is also like the blank slate, like the two.
Yes.
So then with your range
now is different than the previous problems we've been doing.
Yeah, so that would be y. I'll remember it one day. Y line y y is less than or greater equal to +8.
That's right.
And then that would be negative infinity to 8.
Yes, with a bracket.
With a bracket on that. Okay. The brackets on the number, the like.
Yes.
Is that what it's called? I cannot remember.
Which one? The parenthesis?
Yeah, parenthesis. And then
Yeah,
parenthesis with the infinity symbol. Okay.
Okay, so let's have you try one on your own here. You could graph it if you want, but not super important. F of x equals minus 1/2 absolute value x plus 3 minus 4. I want domain and range, and I want vertex, please.
Okay. Vertex minus 3. Or here, I'll just keep it to myself. Okay, got it. Vertex
Okay,
minus
vertex
4.
minus 3 minus 4.
Domain, we all know what that domain thing is. And then negative infinity, and then infinity.
Good. Yep.
And then the range is same thing as the x, but it's y's. And then it's comma y is less than or equal to -4. Then
Okay.
it's quotation negative infinity, comma -4 bracket.
Yeah, parenthesis. You said quotation. I mean, maybe you mean referring to something else, but yeah, parenthesis.
Okay.
Great. Any final questions here? Any other things?
I guess maybe those 2 line graphs I'm a little confused on, where it's like the lines are like not the same. I think I sent a picture to you last time we met, but it's like where it's the graphs aren't actually like they don't necessarily start like an absolute value thing, like they can start in different spots, and then it's like
Like parallel lines
yeah, I think so.
like this? I mean,
Yeah, stuff like that a little bit.
what is your question? Because these have no solution. There is no like 2 lines either intersect or they don't,
Here, let me check the
or
email.
they possibly are the same line.
Yeah. Or I guess like intersection. I sent you. Here, I'm just gonna see what I sent you on email.
Well, I'm looking at it now. I mean, I'm not sure I know what you're referring to.
Oh, okay.
So
I mean, I guess just like very briefly go over that, maybe, if that's possible.
I mean, you're talking about systems here. I mean, the systems have like these possibilities for solutions. Like they either intersect, which is what you want. If they don't intersect, there's no solution. And if they're the same line, they're the same equation. But from what I saw, you're going to get a system with a solution. You're going to get this one up here, system with a solution.
Okay, system with a solution. So that's just something I can look up. And
Yeah. I mean, probably you're over preparing, which is good, but
yeah.
it sounds like you're worried about a really specialized case here that probably won't happen.
All right. Well, thank you for the help.
Yeah, of course. I think your finals tomorrow. Is that right?
Yeah, tomorrow and then the day after.
Yeah, but the truth, probably the best thing is actually just getting good night's sleep, trying not to over stress about it. Stress will really play with you in a negative way.
Yeah.
That's what's really important here. I mean, you've done all the work. You can't make up for a semester or a year of bad habits, and you've had really good habits. You've got your lessons, you do your homework. I would just try to focus on something else besides this until the exam.
All right. Okay, thank you.
Watch a fun movie or something.
Yeah. All right. Maybe I'll go play tennis or something. Who knows?
Yeah. Excellent. All right. Well, thank you, Zach. Thanks for letting me help you, and
All right.
see you next time, whenever that is.
Yeah, I think we're gonna start after our finals. We might do like a little bit of intro into geometry. So
Cool.
maybe we'll have our one our final meet for my freshman year.
That would be great. Yeah, be glad to help. So thanks again. I'll see you next time.
All right, see you, Matthew. Thank
Okay,
you.
bye.